Okay. Okay, let's get started. So let's recap this whole situation. If you want, I've got your sheets now, but if you want to take notes or you'll have the video. But let's just recap the whole situation and then quickly, and then we'll build that A function together like you did for homework to make sure we're all on the same page with that. Okay, so did we do what interval? Did we do intervals of 0.4? Oh, we did 0.5. Okay, so it won't throw you off majorly if this slide has it all for 0.4. Is that okay? All right, so we'll do for 0.4. Okay, so let's see. What are the exact? So I've highlighted this point on the y-axis there. Okay, so I highlighted this point on the y-axis. This is our rate function, right? We've been working with. I highlighted this point. What are the coordinates of that point? Let's see. Angela. Okay. And what would you say r sub v of 0 is? What would you estimate it to be? Yeah, 28. Right, so yes, because the lines are every 4. Every 10, there's 4 lines, so that line would be 27 and a half. Exactly, so a little bit higher than that would be 28. Okay. Next point. Jordan, what's the coordinates of that point? So I've highlighted another point. And what would the exact coordinates of that point be? Okay. I'm saying that's about 17. And we could keep going like that. Easy stuff, right? Okay, and then what did we do? We said we're going to let, in each of these intervals, we're going to take it as a constant rate determined by the rate at the left side. We did that last time, is that right? Okay, and did we call this function r? Oh, I got all kinds of tricks. What's that? This is a PowerPoint. This is a presentation. This isn't a GC file. Yeah, no, this is a presentation mode. Okay, so, and what is this? How would you describe what the function r is? Anyone want to describe to me what the function r is? Yeah, Jacob. Okay, so each one of those is a constant rate over a moment. What about the whole function? What does it do? What is its point? Wrong. It's piecewise, that's true. But what? Okay. And if we've got the exact rate function, why do we want this? If we've got the exact rate function, why in the world do we want this? Right? What's that? To estimate the volume that's already been expelled. Genevieve, what do you think? Agree with that? Okay. Yeah, so other comments. What is the point of this, making this very bad approximation to RV called R? approximation of the rate. Can't we just get an approximation? Can we get? Yeah, I mean, we got the red RV graph. We can get all the rates we want, and they can be exact. So how about somebody new? Let's see. Lauren. Okay, so they both said the same thing. It was about actually getting amount of oil expelled, right? If we've got a continuously changing rate, we can't get the amount of oil expelled. So as soon as you change a little bit in days, your rate is different, and there's nothing you can do. But it's what with these constant rates allows us to actually calculate some changes in oil expelled and some total amounts of oil expelled. Okay. So this thing is what? A new function. It approximates RV, and it gives us a fighting chance to figure out how much oil we have, right? So we've got this rate. So now we have some kind of fighting chance to figure out how much oil has leaked into the ocean. Okay, so just for practice here. Exactly and approximately, what are these values of R? Now this is the R function, the approximate function. Exactly what are those values of R? R.5, R.2, R.9, R.1.1. Go. Work on them by yourself first, and then compare around you. Does that help? Okay, let's hear from some of you guys. So, Sam, what did you think about R of 0.5? Can you represent that exactly? R sub V of 0.5. So what is R sub V of 0.5? Tell me where to stop. Isn't this R sub V of 0.5? So what is R of 0.5? So that's R sub V of 0.5 right there. What would R of 0.5 be? Brianna. She wants R sub V of 0.4. So what this is the y coordinate of this point right here. See that? And I'm asking, what is that y coordinate exactly? R sub V of 0.4. You see? I'm zoomed in, so my pen is very thick. It's like a Sharpie. Okay. All right, you want to keep going now again? Okay, work on it some more. R of 0.5 is the y value on the horizontal, that horizontal blue bar. It's the y value of this point right here. And what is that y value? Where does that come from? All of these y values are what? R sub v of 0.4. Okay, if you're shaky on this, talk this out. Talk this out with somebody if you're shaky. This needs to make perfect sense. Okay, all right, let's regroup. Let's regroup. So, Bianca, did you get R of 0.2? What do you think R of 0.2 is? R sub v of 0.8. So 0.2 is here.
Oh, I'm sorry. R sub v of 0.
Okay. You were doing this one.
Yeah.
Okay, so R of 0.2 is R sub v of 0. Camry, how about R of 0.9? Okay, and Fern, how about R of 1.1?
R sub v of 0.8.
Again, right? Why? Because those two x values, 0.9 and 1.1, they're in the same interval. They're the same interval, so they're going to have the same y value, which comes from what? The y value of the real function at the left side of that interval. Right? Okay, and then so then we wrote that function, right? And what do we get? So we know it's R sub v of 0 from 0 to and then R sub v of Is this consistent with what we said? And your teacher had the equals and on the other side, right? On the right side. And does math operate by means of a democracy? It did, at least at that point it did. Okay, and so then we said, was that where we finished? And we said, okay, now we're going to write this a function. Okay, so how did this go? So now we want to come up with the accumulation of oil. So Morgan, can you get me started? R of x? Okay, what do we think about that? So what? Go ahead, Peter. What's that? Okay, so he's saying that Rx would just be R sub v of 0, and we get a horizontal line from 0 to 0.4, and is that what we want? So Peter, what instead? So that's the rate, but now we're trying to figure out the accumulated amount, right? So we're going to multiply by x. Are we in agreement now? Okay. What about? Okay. So then what about the next line? So take it from here, Ben. Okay. So what are we trying to do? We're trying to figure out. So let's just, can we draw that? So what would that look like? What would that look like? Maybe let's sketch it, and then maybe that will help. So Chloe, what would that little part of the graph look like? Yep. Okay. And so how would I know what to do here? Do I want to go like this? You're saying it's a line? Okay, well, fairly steep. Well, I want to get it right. How do I get it right? Look. 28, okay. Okay. So what is 28 times 0.4? Little less than 14, I heard? Here? 11.2 is less than 14, that's true. Okay, 11.2. Okay, and then you think it's a straight line? Okay, hopefully it will end up straight. Not bad. Okay. Not a consistent occurrence, but it happened there. Okay, so now let's think about this. So we've got what? Here we are. We've got this much oil expelled, and then what's going to happen now at 0.4? The rate abruptly changes, right? The rate abruptly changes. So we want to write how much oil. Now between 0.4 and 0.8, we want to write how much oil. How can I write how much oil is between, or how much oil we get in this interval from 0.4 to 0.8?
Question actually, is it supposed to be R sub v of x or just R of x?
So R sub v of x or R of x? Yeah, so you were using the R function. So R was based on RV, and now the A of x is based on R. Yeah. So A of x is built from R. Okay? So let's go back to the R of x. Okay, so next line, next part. How are we going to do this? Jose? So you're going to start from, you're going to use A of 4? Oh, sorry, 0.4. And what is that? A of 0.4 is what? Okay, what is the meaning of it? Okay, days, right? That's how much we've accumulated up to point days, and then you want to do what? What is this A of 0.4 relative to what we've been talking about in the last 2 weeks? Thing, was that? Oh. Oh, so we got to switch the arrows, huh? Ah. So that means we got to switch the arrows back here too. Oh no. Wah wah. Let's try that again. Oh, we're back. All right, so. Oh, wow. Okay, try it again. Okay, so you see why we do need it this way. You see that? So we can do both on the first interval, but we need it actually to be not equal on the right and equal, sorry, on the left and equal on the right. And so what does that do? So if I were to draw that, so what that does is it makes like a closed circle out here on the right side and then open on the left. So even though we're using the left side, so even though we're using the left side of the interval to get that constant rate, it doesn't start until just after the start of the interval. And then we want to include the right side of the interval at that past rate, at the previous rate, and not the new rate, right? Not the new rate. So every new rate just starts just to the right of the left side of the interval. And this allows us to. Okay. And so then that means that we can use the function. We can use how much we've accumulated in each new line, like the way Jose is saying, 0.4, or A of 0.4. And so what is A of 0.4 relative to all the stuff we've been talking about in the last couple weeks? Initial y. So, and how we now I want to model every point in this next part from 0.4 to 0.8. I want to model every point. And I can do that by initial y. What? What's our change in y? How do we get the change in volume? Rate times x. Uh-oh. How do we get the change? How do we get the change in? Right, it's time the change in x, right? It's times the change in x. What's the change in x? X minus 0.4. So this is this thing we like. You have the starting value, which is how much oil you've accumulated from the previous interval, plus the change in accumulation, which is going to be the rate times the change in x. And the change in x in that interval is going to be, any given x in that interval minus the starting value of x in that interval. And what do we have? Again, we've seen this before. What is that? That's our line, right? That's our point slope form of the line. Okay, so next line from here. Kendall. I ran out of room. Can I do that? Okay, so this is this great advantage to this point slope formula line because we can just pick it up for where we're left off. So how much oil has accumulated at 1.2? How can you express how much oil is accumulated at 1.2? Shayna. Right. So A at 1.2. And what's all this stuff? After 1.2 days, right? So the change since 1.2, right? So all that is the change, like dV, based on rate dx. Okay. So what'd you do? You, in your project for today, you just for sake of having a starting point, we said this was 3, right? And it just was always 3. So now if we actually want to build the whole volume function, it's not going to be 3 plus the change. It's going to be the currently accumulated amount from all the previous intervals. Yeah.
Is the last interval supposed to be
1.6, yeah.
Okay.
Absolutely. Okay. So you in building your program, you did this, but this was just 3. But then all the rest of it was the same, right? All the rest of it, because you were just isolating one of these little segments and just arbitrarily saying it always started at 3 meters cubed of oil. So that should feel familiar. That's what you should have done, something like that. Okay. So the next project. So questions on this A sub x function? Questions on the A sub x function, the accumulation of oil according to this approximate rate. Okay. No questions? So here's your next task. There's that one. Okay, so same context. So I'll get the same rate function, and I'm graphing it from 0 to 3. And then I want to actually get, instead of just one piece of the oil accumulated, I want to get a real function for oil accumulated, just like we just built for the 0.4 intervals. But I want to be able to control the size of the interval. So right now, this is one giant interval from 0 to 3. But if I change n, if I can. Okay, so I just changed n to 3. And that's now showing me 3 intervals. And then the corresponding accumulation function for that approximate rate function. Okay, 10. Okay, here is n equals 6, so that will show 6 intervals. What's that? They're not what?
They're not the same slope, right?
Why aren't they? So she said the colors aren't the same slope.
Like they don't match.
They don't match.
So what is the point?
Each slope on the right is determined by the R value.
But is it just to show the change?
Yeah, I think it helps to show that you're using different rates for each interval to get the max.
Are you seeing the green ones? Maybe you're not seeing.
No, I'm seeing the green
Okay.
one. There's like a purple one, and then there's like a black one, and then
Okay.
that one's supposed to be purple too.
No, I just went purple, green, black, green, purple, green, because that was the mood I was in.
Oh, so it doesn't. It's red. There's no like reference to why they're what they
I just wanted to make contrasting colors so you could see that they're segments. Because when you make n big, then what happens? It kind of starts to smooth out, but you're still graphing segments. Okay. What's that? No. This is the time to introduce this because we're gonna go on to something else. So yeah, so this is the next project. Now let me show you something that this approximate rate function, the blue steps here on the left, okay, that's graphed in its entirety on one command line. And I use this technique that we've seen a couple times now. A is a member of 1, 2, etc. 1, 2, up to 10. Okay, so now I've got N and I've got A, and A allows me to graph all those pieces at once, right? So A allows me to graph all those pieces at once, and then using N, you can graph that blue graph with one command line, okay? And so there's some math to do, okay? You're not just going to sit down at GC and write this out. There's some math to do to kind of figure out what's happening. Now I should say that when I'm displaying less, so here I'm saying displaying 2, it's still graphing all 10 steps. It's just you can only see 2 from 0 to 3. So let me show you. So if I come over here. Okay, so hold on a sec. Let's do one thing at a time. Hold on. Hold on, you guys. Hold on. You guys, please pay attention to where we're at, okay? So hold on to your questions, okay? So what I'm showing you is that even though I've set n equals to 2, so you can see 2 intervals from 0 to 3, it's still graphing all 10 intervals. You can't just see them. You just can't see them. Does that make sense? You can't see them if you just show the x values from 0 to 3. Okay? So it's not that this is making it easier, okay? So it's not I'm not asking you to make sure that it only graphs the ones that you can see. You're always graphing all 10 steps. It's just when you show it from 0 to 3, you get that number of them within the window. Does that make sense? So for instance, here's 8, but the 2, there's still 2 more. They're just outside this window view. Okay, and that's the same thing with this as well. That's the same thing with the accumulation function. So you're always graphing 10 steps and 10 segments. It's just from what you see if you have your window at 0 to 3 changes. Does that point make sense? Okay, so now where the constant rate graph, this approximate rate graph R, the blue one, can be done with one line. I couldn't get this to work out with one line. So I'm telling you, if you can do it, let me know, because I could not get it to work out because of something to do with a slider n. Okay, but so the piecewise accumulation graph, then the only way I can figure out to do it is to require a separate function defined for each piece. Okay, so that will be 10 functions. But once you get started, all you have to do is copy and paste and change it. Okay, so it's a little tedious. That's all it is. So just getting started, getting those first 2 or 3 pieces correct is really the bulk of this assignment. The rest is just some busy work. Okay. Okay. Any questions on this? So someone asked about how do I get as a member of. So on Mac, it is Control equal is a member of. PC, does everyone remember PC? Control Shift E, that's right. Yeah. So Control Shift E on a PC. Yeah.
So your R sub B, did you do the drag and drop thing?
Yeah, so my R sub B, I just highlighted up in the command lines and dragged and dropped. So
PCs can't do that.
yeah, I know. Sorry.
Yeah, so mine was a little weird.
Yeah, so with PC and the labels and the symbols, just do your very best. And I'm not gonna grade you on the computer's inability to do something. Okay. but you still need to make the best effort at it to make the object as effective as possible if you were to use it. Okay. All right. Other questions about this? Did I cover all the bases? So you have to figure out what is A representing, what is N representing. Okay, and then how are you going to create the accumulation function? Okay, so please dialogue with me about this. So be in dialogue. It does not require mathematical things or things in GC that we haven't done yet, but it does require some mathematics that you have to figure some things out. Well, if it's due Tuesday, then there'll be another assignment also assigned Thursday. Okay, this is not a week-long project. This is not a week-long project. But yeah, so we can make it Tuesday. But then there'll be something else assigned Thursday. Oh, so some people want to do Thursday now.
You can turn it in Thursday. If it's due Tuesday, you can turn it in between now and Tuesday.
Yeah, but then we have 2 times the work over the weekend, and we don't just have this class.
He's just saying that if you could do it for Thursday.
Yeah.
Okay. Yours is due Thursday. Ours is due Tuesday.
Okay, other questions? Yeah.
So the command line for A is the set 1 through 10.
No, that's part of the command line. The command line graphs. The command line uses it graphs that blue step function. And part of that command line is using a parameter A, which takes on all these values distinctly.
Okay,
In order,
and the values are 1, 2, 3.
it's going to be that line, yeah.
Okay.
Yeah. Actually, this is what I've written there is actually in that command line. Everyone use that line to do it. That's going to be the easiest. So this. Okay, does this clarify it?
Yes, thank you.
The approximate rate function R is graphs in its entirety on the next command line, and exactly that thing is part of that line. Okay, exactly that. Yeah. So what this does is, so you're going to use A somewhere else in that line.
No,
it's
sorry,
good.
I meant like what does it do?
What was it do? Next Tuesday is fine. Next Tuesday is fine. Okay, so let's do it really quick and it'll be generous. Okay, so we're going to grade it right now. We'll be generous. Ready? Here we go. Okay, 4 points for number 1, 1 for each. 4 total, 1 for each. Meter cubes per second is on the left, y-axis. Seconds on both the x-axis. Meters cubed on the right y-axis. 1 point each. Total of 4 possible. Okay. This is, the red is basically just R sub f of x, right? That's the rate function. So the variables are x and R sub f of x, and it's this rate function. So 2 points for something like that. Okay, A is 5.2, comma, R sub f of 5.2. 2 points. B is 5.2, comma, f of 5.2. 2 points. So that one's worth 4. Okay, we gotta hustle. All right. The blue segment is approximate rate. Approximate rate. Approximate rate for this moment of 5.2 to 6. Estimate of the rate. Estimate of the rate or approximate rate. That's right. Estimate of the rate or approximate rate. 2 points. Sure. Okay. Vertical segments. Right? The horizontal segment is dx, and it equals 0.8. And this one is df. And how do we get the change of y given the change in x? It's r sub f of 5.2 times dx 0.8. Okay, so if you had just df and dx plus 2, bonus point for writing 0.8, bonus point for writing this expression, r sub f of 5.2 times 0.8. Bonus point. That's fine. So if you have, so the segment, since it's changing, you could have it as x minus 5.2, that's fine. I'm doing the final value of the segment. Sure. Okay, the coordinates of point C are what? 6 and yep, f of 5.2 plus this, r sub f of 5.2 times 0.8. Why is it not f of 6? So yeah, so we can assume we got the right amount of concrete at B, but then because we're approximating with this blue line, this is an F. We're not making F. We're making an approximate of F, right? So that y coordinate of point C is not f of 6. It's close to f of 6, but it's not f of 6. So it's f of 5.2 plus r of f of 5.2 times 0.8. Does it make sense? What's that? 2. All right, and then equation of the purple line. Let me just write it. I'll write it in blue, or I'll write it in red. Here, the equation of the purple line would be y equals r sub f of 5.2 times x minus 5.2 plus f of 5.2. So, most important thing, you understand it. If you didn't, how many people got the line segment right, the purple line segment? More than half? Yeah.
About the whole, because we defined f as the moment from 0 to 45, why is the point not?
Wait, f is not a moment.
Didn't you just say change of?
A moment is an interval of x. F is the true concrete forming function.
Why is B f of 5.2? Why is the y value for B?
How many is the last
F of 5.2.
Everyone give yourself 20 out of 20. It was supposed to work out that way anyway. I was trying to shoot for lots more than 20 points, so everyone